I'm Jeff Yarger. I'm a professor of chemistry, biochemistry, and physics at Arizona State University.
And I'm Vladimior Mujica. I'm a professor of chemistry and biochemistry at Arizona State University School of Molecular Sciences.
So we're here today to introduce BCH 341 at ASU, the online course version for this for the spring semester of 2019, which is physical chemistry with a biological focus. And so we're co-instructing this, and we'd like to give students kind of a flavor of what you're going to see throughout this semester and why we consider the material we're going to cover important for a degree in biochemistry.
There is one thing I would like to take from the very beginning, which is the title of the course. Physical chemistry with a biological focus. So physical chemistry, it's by itself an interdisciplinary branch of science where physics and chemistry are combined. Now, a biological focus, what we try to say there is that we are going to be concentrating on the type of physics and chemistry we need to describe the behavior of biological systems. As it turns out, it is very different from what happens with non-biological systems.
Yeah, exactly. And so, the first idea is that, like you said, we're going to be using physical chemistry concepts and focusing on the ones that are really important for biological systems. And this is going to start with looking at thermodynamics. It moves on to looking at time processes through kinetics, and eventually to get through physical chemistry, you need to move into molecular realm or quantum realm and spectroscopy. Now this course, in a sense, physical chemistry is covered, or biophysical chemistry is covered in kind of two courses at ASU. This one and 463, which is where they where they do cover the molecular aspects of physical chemistry. And so this course is mainly looking at the thermodynamics and timescale or kinetic processes in this system.
And as you mentioned, it's quite interesting that there are many things we can learn about biological systems without taking into account the biological system consists of molecules. I mean, thermodynamics, for instance, we can talk for hours about thermodynamics without having a molecular description of a system. And this is going to give us a conceptual advantage as we proceed. Eventually, there is no way we will have to take into account that biological systems consist of very complex molecules interacting with each other. But we will see that it is possible to cover a lot of material thinking of a biological system with not necessarily a discrete molecular description.
Right. And I think, for me anyway, physical chemistry always roots itself in the foundations of the mathematics we need to describe it. And so a lot of times students will ask, we've seen thermodynamics in introductory chemistry, physics courses, etc. We're coming back to it, and yes, we're looking at biologically focused materials, but at the same time, I think we're going to come back to it and look at it from more mathematical rigor than a lot of students in biochemistry have seen.
And this turns out to be extremely important. Mathematics is not an obstacle. It's actually a way to help understanding concepts. I mean, for instance, let's talk about a very simple thermodynamic example. Probably we have all heard about Carnot engines and thermal engines. So the question, are we human beings, are we thermal engines? Can be, think of ourselves as that can be described as a thermal engine. The answer is, to some extent, yes. We are irradiating heat, and from that point of view, if we don't take into account our internal processes, it would be okay. But if we want to take into account our internal processes, then the situation becomes much more complicated, because part of the, let's say, protein synthesis entropy is not increasing, just to mention one key thermodynamic idea.
Yeah. And I think to extend that, yes, we're going to come back and look at thermodynamics, but we're going to do it not only with a biological focus, but with a mathematical focus, so that we can really get a lot more in depth with our understanding of this macroscopic theory. And I think the same is true in kind of the time scale or kinetics and its relation to non-equilibrium thermodynamics. And
and I think this is an extremely important point, because very often we hear this idea that if you're going to teach something with a biological focus, then why do we need mathematics? The reason is that without the mathematics, there's no way to talk about science in a way that could be used to predict. You can use words, of course, but equations, they really help a lot. And we are going to try to combine words and equations so that we understand concepts.
Yeah. So hopefully that gives you a flavor of what we're going to try to do in this course. We look forward to seeing you in the spring, and good luck.
Yeah, for sure. Thank you, Jeff.
Yeah.